Okay, today we'll continue to preliminary subsection, which was the P4, and it was functions and their graphs. Okay, and let me write it. And P4, functions and their graphs. Okay, and the y equals f of x, and the f, as you know, function symbol, and the x independent value, and it represents an input value from domain of f. And we will denote it by the capital of D of f. It means domain of f. Okay, and the y, it denotes dependent value, and it represents an output value f of x in the range of f, and this is the range of f. Okay. And let me continue with the domain convention. F of x equals to x squared, and the domain of f equals to, okay, and it's half open interval, which is from 0 to the infinity. Okay, and that means x is larger than or equal to 0. Okay, and another function, which is g of x, it equals to x squared, and let me define its domain by the d of g, and it's infinity minus infinity to plus infinity open interval, and that means the x element of the real numbers. Okay, that means, so as you see, maybe you can think about these functions are same because of, as you see, both of them are x squared, but their domain set is different from each other. So we can say they are not same function and they are not equal to each other. And let me write it. They are different functions because they have different domain, as you see. And then what can we say as the result of this domain convention? And We can say when a function f is defined without specifying its domain, and we assume that the domain consists of all real numbers x, for which the value f of x of the function is a real number. Okay, don't forget it. If we define without specifying its domain of function, okay, and we will assume that the domain consists of all real numbers x, for which the value f of x. Okay, don't forget it. And let me show some example about these conventions. X and the t of x function equals to x squared plus 7 over x minus 7. Okay, and the domain of t function, okay, that must be minus infinity to 7 open interval union, okay, plus 7 to plus infinity open interval. Okay, as you see in the denominator part, we have x minus 7 when it equals to 0 and x equals to 7. Okay, and this part will be must be subtracted from the whole real numbers. Okay, because it will be undefined. And the continue example again. And the g of r function square root of r square minus 4, and the r square minus 4 larger than or equal to 0, so r square is larger than or equal to 4. And the what can we say about it? Now we can say r larger than or equal to 2, or r is less than or equal to minus 2. So domain of g, okay, can be written by the minus infinity to minus 2 half open interval union plus 2 to the plus infinity set. Okay, and let's continue with this sketching some graph of function. Cartesian coordinate systems has just been drawn here, and these are some special graph, okay, and you will learn these graphs in the other and the next lecture hours. And firstly, this function is y equals to square root of x, okay, x and y, and this function is y equals to x cubed or x to the power of 3, and this is x to the power of 1 over 3. Okay, and let me continue. Okay, and another function graph like that. symmetric to the origin, this graph, and it was y equals to 1 over x, okay, x, y, y, x, x, y, and the other function y equals to 1 over x square, and the last important function this is y equals to absolute value of x. And you can see more graphs at the page 27 in your book. Okay. And let me continue with the some example. Sketch the graph of the function f of x equals to 2 minus x over x minus 1. Okay, and let's recalculate or reorganize this function, okay, by adding some values or subtracting some values, okay, and we will see two simple form of this function by defining the some graphs which are shown above, okay, which I have just shown above, and we can write the numerator part like 1 minus x plus 1, okay, and the denominator part can stay same, and the denominator we can write 1 minus parenthesis x minus 1 and the plus 1, okay, or x minus 1, and so we can write it minus 1 plus 1 over x plus 1. I'm sorry, minus 1 plus 1 over x minus 1, okay. As you see, we know the y equals to 1 over x graph from the above, as you see, okay. As you see, sorry, we know how to sketch the 1 over x graph, okay. And now we can say this is the this is the same function, and we can shift this function 1 over x function the right, shift right 1, and shift down 1 unit, so we can evaluate the minus 1 plus 1 over x minus 1, okay. As you see, you must shift it to the right 1 unit, and you must shift it down, okay, and shift it down 1 unit. So what will we obtain? Okay, let me sketch it on the Cartesian coordinate system, okay, and let me sketch firstly the 1 over x function, okay, 1 over x function, and the 1 over x function like that, right? Yes, this is 1 over x, y equals to 1 over x. And what did I say? I said you must shift it right to the 1 unit, okay, that means, I'm sorry, yes, shift it right to the 1 unit. For example, this is the plus 1 asymptote, and shift it down to the 1 unit. This is the -1 asymptote, okay, and now you can sketch your function, okay, which is -1 plus 1 over x minus 1 by the meaning of the 2 minus x over x minus 1, this function, okay, and it will be like that. Look at the green pen, and this green pen equals to 2 minus x over x minus 1, and it equals to -1 plus 1 over x minus 1. Okay, now we can talk about the even and odd functions, also symmetry and reflections of the functions. Okay. Definition. Suppose that x belongs to the domain of f whenever x does, we say that f function is an even function if f of minus x equals to f of x for every x in the domain of f, and by the mathematical representing, it can be written like that for every x element of domain of f. Okay, and another definition about the odd function, we say that f is an odd function if f of minus x equals to minus f of x. Okay, when for every x element of domain of f. And let's sketch simple example about the even and odd function on the Cartesian coordinate system. For example, if your function is even function, okay, your graph will be like that. Okay, and for example, when you select any x value on the x-axis, okay, and its projection on the y, and the same as minus x will be here, okay, and the c is projection on the y, and this part will be equal, okay, and we can say this f of x function is even function, and all even functions symmetric, okay, about the y-axis, okay. As you see, this function symmetric about the y function, and the symmetric of this blue curve, you can find the right hand side of y-axis samely, okay. And let me continue with the odd function graph. So it's same, and for example, this is y equals to f of x, and when you select any x, okay, like that, I'm sorry, and this part is x minus x, okay, and this part is of course minus y, and this part is y, okay, and this green vertices are same, equal, okay. And what can you say about the odd function, okay, and the y of f function is, this function is odd, and it is symmetric about the origin, okay. Okay, and the reflections in straight lines and for example, this is y equals to square root of x, okay, and this green curve is y equals to square root of minus x, okay, and this is the reflection of the y-axis for this function. And let me sketch another one, which is y equals to absolute value of x, okay, and this green pen will be minus y equals to absolute value of x. Okay, and you can find more reflections graph in the page 29. Okay, and now I'll continue with the preliminary 5, which is the combining functions to make new functions. And let me give a break, please, and 20 minutes later we will continue with the P5 subsection. Okay.